Welcome back. We are talking trigonometry. Previously in lesson 8, we were looking at how to use the addition formulas to answer questions along that line. So, when given cos of A and cos of B as those ones where A and B are acute angles, and you're told to find the value of cosec of A plus B. One particular thing I want to remind you of is cosec is 1 over sine. So it will be 1 over sine of A plus B. But remember, this one is 1 over sine A cos B plus cos A sine B. Now check and see what do we have and what don't we have. Okay? What do we have? What don't we have? What do we have? We have cos B, we have cos A. Do we have sine A? No. Can we get it? Yes. From here. If this is our A, if that is our A is the angle. Cos is 3, this is 4. We've discovered that that is a 5. No. It is 16 minus 9. We have 16 minus 9 giving you a 5. So this is root 5, not 5. This is root 5. We have a squared plus b squared is equal to c squared. So our A, we don't know. Our B is 9. This one is equal to 16. So a squared plus 9 minus 9 is equal to 16 minus 9. That one will cancel. That one will cancel. And 16 minus 9, that one gives you a 7. Yes, it gives you a 7. So A is the square root of 7. We have a 7 there. We have a 7. 16 minus 9, you have a 7 there. Now, if that is root 7, we can get the value of sine A. Sine A is going to be root 7 over 4. Then we need to look at B. This is 13. This is 12. That is 13. So still a squared plus 144 is equal to 169. So a squared will be 25 and A will be, what will A be? A is going to be a 5. So we have a 5 here. Therefore, sine B is 5 over 13. So you can go and substitute there. We have 1 over sine A is root 7 over 4 into cos B. Cos B is 12 over 13 plus cos A is 3 over 4. Cos A is 3 over 4. And sine B is 5 over 13. It is 5 over what? 13. So, on simplifying by 4, 1 by 4, 3. I think. So we have 1 over. Now from there, this is the 3 root 7 over 13 plus, from here we have 15 over 15. We have 4 times 13 is 42. We have 4 times 13. It is 52. It is 52. So your role is to simplify this from down here. Okay, we have 1 over the LCM is 52. So this one will be 12 root 7. Okay, 12 root 7 plus 15. Okay, or it can be written as 52 over 12 root 7 plus 15 as the value of cosec of A plus what? Plus B. As the value of that. Okay? As the value of that one. Now, you can also have another question. Guiding question. We can have if sine of x plus alpha is equal to 2 cos of x minus alpha. Want you to prove that tan x is equal to 2 minus tan alpha over 1 minus 2 tan alpha. 1 minus 2 tan alpha. Let's look at the solution. We have sine of x plus alpha is equal to 2 cos of x minus alpha. Let's use these ones and see what we come up with. From here, if I expand, I'll get sine x cos alpha plus cos x sine alpha. This one is equal to 2 into cos x sine alpha. No, it is cos x cos alpha. It is a cos. Then we are subtracting, so this one is going to be a plus. Plus sine x sine alpha. Okay? Yes. We have sine x cos alpha plus cos x sine alpha is equal to 2 cos x cos alpha plus 2 sine x sine alpha. Okay? Now, I can bring the signs on one side. I mean, there are some elements. There is this element. I can bring this on the left hand and take this one the other side. So I can have sine x cos alpha minus 2 sine x sine alpha. This one is equal to 2 cos x cos alpha minus cos x sine alpha. Now, there is a common factor here because what we are interested in is the tan x. The common factor is the sine x. If I factor out sine x, I'll remain with cos alpha minus 2 sine alpha. Okay? Now the other side, still cos x is common. So you can have cos of x into 2 cos alpha minus sine alpha. Okay? Now, at that level, let's think of what? At that level, we can think of dividing both sides by cos x. Now if you divide both sides by cos x, you'll have sine x over cos x into cos of alpha minus 2 sine alpha. This one is equal to cos x over cos x into 2 cos alpha minus sine alpha. Okay? Now this one will cancel with that. Here we have a tan x into cos of alpha minus 2 sine alpha is equal to 2 cos alpha minus sine alpha. Okay? Now since we need a tan x, you make it the subject. You divide by cos alpha minus 2 sine alpha by cos alpha minus 2 sine alpha, such that this one disappears and you remain with what? With a tan x. So if you remain with a tan x is equal to 2 cos alpha minus sine alpha over cos alpha minus 2 sine what? Sine alpha. But what they want is in terms of tan alpha. So what you do, on your elements on the right hand, you divide through by cos alpha. Okay? So you'll have tan x. Tan x is equal to, here you have to, if you divide by cos alpha, the cos disappears. There you'll have a tan alpha over, here if you divide, this is a 1, there you'll have a minus 2 tan alpha as required. As what? As required. So we can use those addition formulas as we listed them down to solve or even to prove identities. In case you are told to prove or to come up with a certain identity, or you are coming up with a certain identity. Okay? Yes. Now, as you can see, we are now moving to double angle formulas or double angle formulae. Double angle what? Double angle formulae. From sine of A plus B, we discovered that this one is sine A cos B plus cos A sine B. Is it so? Yes. If A is equal to B, if A is equal to B, that means we do have sine of A plus A. In other words, if I press A in the place of B, I do have something like that. So sine of A plus A will become, I'm replacing A with, sorry, B with the A. So I have sine A cos A plus cos A sine A. Now from here, you can see that you have two A's. When you add them up, you get sine 2A. Now, this side, we have sine A cos A plus, I can also decide to start with a sine, and I have sine A cos what? Cos A. Let me remind you. Recall that 2 times 3 is 6, and even 3 times 2 is what? So multiplication, the order of arrangement doesn't matter. That's what I've done here. So therefore, sine of 2A is equal to, we have this, so it is equal to 2 sine A cos A is equal to 2 sine A cos of A. Cos of A. Now, let's look at a cos. Cos of A plus B, we discovered that it is cos A cos B plus cos, it is a minus sine A sine B. Okay, and for A is equal to B, if the two angles are equal, that means I will have cos of 2A. So cos of 2A, from there I have cos A minus sine A sine what? Sine A, which is here you have cos squared A minus sine squared what? Sine squared A. This is cos of 2A. Now, for cos of 2A, I have equation 1 there. Let me call that one equation what? Equation 1. Let me call that one equation 1. So if that is equation 1, from cos squared A plus sine squared A, we get what? That is a trig identity. We proved it. So if I make sine the subject, if I make a sine the subject, I mean sine squared A, what do I have? I'll have 1 minus cos squared A. Okay? Now you substitute for sine squared A in equation 1. In equation 1, if you substitute for sine squared A in equation 1, you'll have cos of 2A is equal to cos of squared A minus 1 minus cos squared A. So we have cos squared A minus 1 plus cos squared A, which is this with this, when you combine them, you get 2 cos squared A minus 1. This is cos 2A. You call this equation 2. We are going to pick it up from there in our next lesson.